Let's solve some problems here. Given the function f of x equals 2/3 x minus 5, what input value corresponds to an output of 3? Now, to solve for the input value given the output value, let's recall that any function f of x, in any function f of x, the x is the input value. And the result, when you plug in the input value to the function, or the value of y or f of x, that one is the output value. So in this given problem, we're given here this function and then an output of 3. So the value of 3 here is the value of f of x or y, or the result. So we should plug in 3 to f of x and we solve for the value of x. So let's do that. So let's plug in the value of 3 here to f of x equals 2/3 x minus 5, and then we add 5 to both sides. This cancels out, so we have 8 equals 2/3 x. Okay, and then we divide both sides by 2/3. Okay, so the value of x is just 8 over 2 over 3, which can be written as 8 times 3/2. And 8 is divisible by 2, so 8 divided by 2 is just 4. Therefore, the value of x here is 4 times 3, and that is equal to 12. So our input value is equal to 12. What value of x satisfies the equation 2/3 5x plus 7 equals 8x? So we're given this expression here. We just have to solve for the value of x. We can either distribute 2/3 to the expression inside the parentheses, or we eliminate the denominator 3 first by multiplying both sides by 3. So you can use either way, but the first method is a bit complicated, so let's just multiply both sides by 3. So that is 2/3 times 5x plus 7, okay, times 3 equals 8x times 3. So 3 here cancels out, and we're left with 2 times 5x plus 7 equals 24x. And then we can distribute to the expression inside the parenthesis, which is 5x plus 7. So that is 2 times 5x, that is 10x, plus 14 equals 24x. And then we subtract 14 from both sides. This cancels out. So we have 10x equals 24x minus 14. And then we subtract 24 from both sides. This cancels out. So we have 10x minus 24x. So this is negative 14x equals negative 14. And then we divide both sides by negative 14. Therefore, the value of x is equal to 1. So 1 is the value of x that satisfies this equation here. If the slope of a line is negative 7 over 4 and a point on the line is 4, 7, what is the y-intercept of the line? Now, to solve this problem, we can use the linear equation, the slope-intercept form, y equals mx plus b, where m is the slope, okay, and b here is the y-intercept. So we're given the slope, which is equal to negative 7/4, and a point on the line. So we just have to find the y-intercept, which is the b. So since we're given a point here, which is on the line, we just have to substitute that value. This is x, the value of x and y, to the equation. Then we can solve for the y-intercept. So that would be 7 equals negative 7/4 times 4 plus b. So 4 here cancels out. So we have 7 equals negative 7 plus b. And then we add 7 to both sides. This cancels out. So we have 14 equals b. Therefore, the value of our y-intercept is equal to 14. Which of the following expressions is equivalent to 25x squared minus 4/9? We're given this expression here, 25x squared minus 4/9. The expression given here, 25x squared is a perfect square, and 4/9 is also a perfect square. So this expression is a difference of two squares. So we can write each term as a quantity squared, and then we use the rule a squared minus b squared equals a plus b times a minus b. So we have 25x squared minus 4/9. So this can be written as 5x squared minus 2/3 squared. And by using this, we can write this one as 5x plus 2/3 times 5x minus 2/3. So this is the equivalent expression of this one. So the answer here is letter C. Which of the following equations could represent a parabola that has a minimum value of -5 and whose axis of symmetry is the line x equals 1? We're given here the minimum value of -5, which is also the y-coordinate of its vertex, the vertex of the parabola. And then the axis of symmetry also passes through the vertex. So by using these properties here, we can identify the vertex, and then we can use it to write the equation of the parabola, which is y equals a times x minus h squared plus k, where hk is the vertex. If the minimum value of the parabola is -5, therefore the vertex of this parabola is just x -5. And it says here that the axis of symmetry is the line x equals 1. Then that means the x coordinate is equal to 1. So this would be 1 and -5. So now we can write the equation of the parabola. So we can just plug in the value of the vertex here. So that would be y equals a times x minus 1 squared minus 5. So this is now the equation of our parabola. We don't know the value of a, but in our choices here, the value of a in all of the equations from A to D is just equal to 1. So the answer here is letter C. If A equals x squared plus 4x plus 9 and B equals x cubed plus 6x minus 2, what is 3A plus B? Now to solve for 3A plus B, and given the value of A and B, we just have to substitute or plug in the values here. So that would be 3A plus B equals 3 times x squared plus 4x plus 9 plus x cubed plus 6x minus 2. And then we can distribute 3 to the expression inside the parentheses. So this is 3x squared plus 12x plus 27 plus x cubed plus 6x minus 2. And then we group like terms. So we only have 12x and 6x as like terms, as well as 27 and negative 2. Then we can arrange them from the highest order or the highest exponent. So this would be x cubed plus 3x squared, then 12x plus 6x is 18x, then 27 minus 2, this is plus 25. So 3A plus B is just equal to x cubed plus 3x squared plus 18x plus 25. So the answer here is letter C. How many real values of x satisfy the quadratic equation 9x squared minus 12x plus 4 equals 0? A quadratic equation can have 0, 1, or 2 resolutions. So there are several ways to determine exactly how many. We could graph this equation, or we can calculate the discriminant, or we can factor this. We can check if the first and the last terms are perfect squares. So you can just choose which one is easier and quicker for you. So in this given quadratic equation here, have you noticed that the first term 9x squared plus and positive 4 are perfect squares? So this is a hint that it could be a perfect square trinomial, which is right. So let's just factor this quadratic equation. We can do okay, so 9x squared can be written as 3x n squared. So 4 can be written as 2 squared. So we can just write this as 3x minus 2. 3x minus 2 equals 0. So this is 3x minus 2 squared. Since both factors are just the same, therefore there is only one real value for x. So that is 3x minus 2 equals 0. Add 2 to both sides. 3x is equal to 2. And we divide both sides by 3. So x is just equal to 2/3. So there's only one real value, which is x equals 2/3, that satisfies this equation here. So the answer here is letter B.